move on to this. Okay. So this is parallax, and so basically we have two images taken by the airplane, and then the first one is over here, and the second one is over here. And assuming that we have 2 points on the ground, A and B. A appears at on the first image at A, and appear as on the second image at A plane, and B as well, B and B plane. And you have two O, which indicates the principal points, O and O plane. So we have two images, and then what we can do is we can put these two images together so that their origin are matched with each other. So O and O plane are here. So we have two images, right? What we are doing is we directly put them together. Right? We directly put them together. So their origin match with each other over here. But however, as you can see, let's go back to the previous slide. So as you can see, for the first image, the A and B, these here, A and B, they appear over here, A and B. So on the right hand side of the image. And for the second image, A and B, so A plane is over here, near the principal point. B plane is on the left hand side of the image. So after we put them together, then their relationship becomes like this. So for the A and B, those are from the first image. A and B are from the first image. A plane and B plane, they are from the second image. So the distance between A and A plane, that's the x parallax of the A. That's this PA means the x parallax of A. And the distance, from the B to B plane, that's the x parallax of B. That's the x parallax of B. So that's, well, as you can see here, the PA parallax A, parallax B, that's the XA minus XA plane. Right, so that's the definition of the x parallax. Right, that's the definition of that. So the reason that there's a difference because they are, as you can see, the size of the x parallax for the A and for the B are different. That indicates the size of the elevation or the depth of those 2 points. And basically that's it means that x parallax is information that you need to indicate the depth. Right. So what's y parallax? The y parallax, let's take a look. So here, if you put two images and then side by side, these two images side by side, and then you have the corresponding points, for example, A and B over here, and you have A2 and B2, A1 and B1 and A2 and B2. So supposedly they need to match with each other. And right now, because you have some kappa arrow, for example, like this, you have some arrow to like properly oriented these two images. Then, as you can see, you can imagine this one is what you see from your left eye, and this one is what you see from your right eye. So supposedly, these two eyes, these two lines, they can form two light rays. So one, the first light ray is passing through A1, and the other light ray will passing through A2. And supposedly these two light rays, they will intersect. So you know where that is. Okay, this is called focusing. And however, if you have some arrow, for example, like this copper arrow, then this copper arrow will result in something, which is your light ray from the left eye will not intersect with the light ray from the right eye. And these two light rays, they won't intersect. So, which indicates that the y parallax, if the y parallax is small, then although you cannot directly match them perfectly, but you can still like kind of see that object. But when the y parallax getting larger and larger, then at the end you couldn't see the like stereo scoping. You couldn't see the stereo. So that's the y parallax. So as you can imagine, the y parallax indicates that originally these two light rays they can intersect, but because you have y parallax, so these two light rays were gradually separated from each other, and then eventually they could not intersect. Okay, so that's the white parallax. Okay. Okay, any question? I go over it a little bit quickly, because of time. So any question? 横视差、中视差? Right? No? Okay. So if not, then let's go back a little bit. Okay, so and here is about how to view to get some how to view the stereo pairs. There are many ways. The first one is from a naked eye. So I believe actually this is similar to the first chapter. So the first chapter has two drawings, and then you can try to force your right eye to see the left image, your left eye to see the right image. Then you can see the stereo. Okay, so this one as well, and then this one I believe it's 中央大学. Yeah, right. It's NCU actually. Yeah, here is the front gate is up here. This is the front gate. Alright, up here. So this is from the old time actually, the old era photo for the NCU. So if you can, force your eyes to force your eyes, and then you can see the old time, the NCU in the old time. Okay. Okay, and this one is very difficult to see because there's not much clear features to focusing your eyes. So it's very I don't know, painful to see if you are trying to Anyway, so if you couldn't see the stereo from these satellite pairs for the mountainous area, then yeah, it's fine. It just have the same. It has the same meaning. And the other way is by using the red and also green, red and green glass, and then you can see the stereo as well, and then to block the other half of the image. Okay, like this. Okay. And still, did you guys see this in the lab? Okay, yeah. So basically, that's the Taiwan. You can see the Taiwan immersion through that. And did you guys change the? Okay, so if you notice, this one, the left one, we have this not stable. We have the tab to fix the location of it. And for the right one, actually you can move it. And if you next time, I don't know whether you guys try it, but next time you can try to move this to the Y direction and to the X direction, and see how does it change. And like I said, if you move it to the Y direction, then as you can see, supposedly your two eyes will imagine this optic you can say optic system. It can it can tell you that here we have a light ray from the left eye, and we have the other light ray from the right eye, and we can intersect. But however, if you have the Y axis movement, then which means that these two light rays they will separate from each other. So the more you move toward the Y direction, then the higher chance that you couldn't see anything. Right? We couldn't see the stereo. Okay. But however, if you move to the X direction, supposedly you will see the elevation of the mountain or elevation of the Taiwan getting more steep or more flat. Okay, more flattened. Alright, so if you didn't try it, feel free to just go to the lab and try it. Okay, so that's this one. Okay, so yeah, this is the assumption. So as you can see, we need these two images need to be properly oriented, so that you can remove all the Y parallax and then only the X parallax will match. So yeah, these are some conditions that you need to meet. And here is what we talk about, X parallax and Y parallax. So sometimes, for example, you can also try to rotate it. So if you didn't properly orient it, and because of the copper differences, then that's the problem. Or these two images, they are taken from the different elevation, from different flight height. One is taken has a larger scale, one has a smaller scale. then you have something like this. Then how can we fix this problem? How can we fix this problem if these two images, they have two different scales? It's a very simple solution for that. How can we fix it if they have two different scales? Yi, what do you think? Take another photo to have the same scale. Yes? Okay. That's another way, but however, taking another photo, like I said, every time you launch the airplane, it's very costly. It's very costly, so may not be a very good, cost-effective way. Chih-Yuan, what do you think? Is there any simple way to solve this problem? No? Okay. William.
Use that transform.
Transformation? What kind of transformation?
Maybe R5.
A fine transformation. Basically, you just need to rescale it. I believe, I believe like Ray, those guys were talking about it. You just need to like zoom in a little bit more. Okay, so kind of like that. You just need to do that. If the only difference is in terms of their flight height, and it's in terms of their flight height. But if the situation is like this, you have one has a little bit of tilt angle. Then in this case, it's not only the zoom in and zoom out. Okay, in this case, you need to do what? In this case, you need to do what? Ethan, what do you think? Imagination. Oh, imagination. Oh, I need to do something imagination. Okay, okay. Image fusion. No, not image fusion. Deborah. No idea? Great. What do you think?
Fixed information, like referring that picture to that picture. That makes some georeferencing again.
Georeferencing again. Kind of like that. What you're saying is like more general process. It's a little bit more general process. But here, okay, let's just say we have some like tilt angle. Basically, we have some tilt angle. Then this one is like a vertical photo, and the other one is the tilt angle. It's a tilt photo. So what we can do is we can perform the tilt correction. Just need to perform the tilt correction. And as you can see, the shape differences is like square to trapezoid. So we can just directly use the 2D projective transformation to perform to correct the tilt displacement. Then we can have another vertical photo as well. Okay. So it's not only the like zoom in and zoom out, however, it's just like 2D projective transformation. So not very difficult as well. Alright, so that's the case. Okay, so basically that means if you have some, you need to remove the y parallax. The general idea is you need to remove all the all the y parallax, and then in this case you can use the x parallax to see the stereo. Okay, so that's basically the case. This is from the old time. If you are viewing the stereo pairs by using your eye, then you may suffer from something called vertical exaggeration. I forgot the Chinese term for that. Exaggeration means like 夸张 or 夸大, and vertical means that basically it means the elevation you are seeing is not the real elevation. Because like your eye base, the distance between your eye may not be similar to, of course not similar to the distance, the baseline for these two images, but however the ratio of them, the ratio of the base to height ratio are different. So you may usually have some exaggeration in terms of the elevation when you are using your eye to see the stereo. So this is in the old time, so just for your information. But this is important, base to height ratio. And we talked about this for like quite a while, so yeah, I'm not going to repeat that, but remember that. This is for the old time as well. You can use something called parallax bar and also floating marks to fix. This is the parallax bar, and this one is fixed, and then this one is movable. Oh, sorry, this one is fixed, and this one is movable. So to measure their parallax. So and to do some calculation. But this is also in the old time. So in Chinese, it's called 视差尺, parallax 视差 bar 尺. Right. Floating marks is called 浮标. Right. And this is also for the old time, so it's not very important right now, parallax equation. So when you have a parallax and then measured, then you can calculate the height and through the equation over here. So yeah, like I said, not very useful nowadays. Yeah, these are also the old informations. So okay. That's pretty much about what we have for the chapter 7. Any question? Any question for what we talked about today? Alright, if not, then tomorrow we will continue other chapters. Okay, so see you guys tomorrow.